Hi guys. I'm gonna solve this problem 515, the number, and then Facebook a lot, Amazon, Samsung, LinkedIn, 1 and 2 years. So it's kind of old problem, but and the acceptance rate is 64, and then the number is kind of old one, not very old, but kind of old. So I guess this problem may not be very difficult, I hope. And it has a lot of likes and very little dislikes. So let's try to solve this. Given the root of the binary tree, return an array of the largest value in each row of the tree, 0 indexed. 1, 3, 5, 3, 9. So this is a binary tree, not fully packed tree, but so when you see this kind of problem, what I can imagine is that BFS, breadth first search, yeah, BFS will be traversal, breadth first, BFS, BFT, what's the name? But anyway, so first we're gonna look into this, and then we're gonna push this, and then we're gonna pop this, and then we'll try to see whether which one is the max one. So so having the max one seems like it could use max heap, but if we have the way to iterate everything, we don't need to keep maxi. We can just use standard max function. Yeah. So one way of doing that is that when we insert one element, we can also insert some kind of depth information. So and another way of doing this, I guess, is we can use 2Q. First one is this, second one for this, and then we can use the first one for these two. So that's another way to solve this. But here I'm gonna use 1Q with depth information. So we'll use Q, and then the Q will have pair, and then first one should be tree node pointer, and second one should be depth, right? Q. So the parent is pretty same. So Q push root, and then while not Q empty. What you're gonna do is Q dot pop, not pop front, right? And then this will be auto pointer node, and then Q dot pop this node info. Let's say info, node info. So the typical pattern is like node info, and then if node info, so we're gonna have some kind of depth, new depth, next depth. This is node info dot second plus 1, right? New depth. So if this has the right, then what we can do is that we can push q dot push and then make pair this one and next steps. And if this is the left, let's do the left first, because that's pretty much the convention, I guess. So this is the way, and in here what we need to do is we're gonna create some kind of vector int answer, right? And then so the tree will be, the number of nodes could be 0. So in that case, probably we need to return 0. So if root, not root, then we can return empty, right? So here we know that if this is not root, make pair root, let's say 0. So the depth is actually the index of the vector, right? So so what we can do is that since there is only one, push back root fell, right? And then here what we can do is if so whether this node is the first node in the vector in that depth, or some other some next node in that depth in the depth. So to check whether this is the first one, so we can see the size. So this is node depth, right? So this is this one, and then so for the root node depth is 0 and size is 1, so we have to add 1, right? So what this means is that there's already some number for this depth, right? We may not need this, so we need to do something, and then else we can just answer push back node info dot node first the val. So here well, so answer dot answer we need the last one, so R begin. This is the last one, and this is current max. That's this one. So if current max is less than node value, so node info that node the first val, then we need to switch this, right? Let's get it as a reference. I think this will be okay. We are not gonna change the iterator, so in that case we can change the current max to this value, right? Or if there is nothing, we just push it to here, and then finally we can return answer. So so let's say empty case, this returns empty, okay. And if we have only one, like 100, like 10, okay. So here empty 10 will be pushed, so 10 will be popped, and then node depth is 0, and answer flag is 0, and then this is 1, so we're gonna go into here, and then 10 will be pushed back to answer, and then these are all, you know, empty, so we'll return 10. And then let's do this. So 1 is pushed initially, and then here we're gonna push 3 and 2 with depth 1. So here 3 is popped, and then 3 is pushed here, and then the next one 5, 4, 3 will be pushed, and then here 2 is popped. So now this is 2 and this is 1, so here current max is 3. 3 is less than 2, no, so this will not be executed. But anyways, the next one 9 will be pushed, and the next turn 5 will be popped, and then this will be 0, 1, 2, and this is currently 2, so not match, so 5 is pushed, and then next pop 3, so here 3 and this is 5, so nothing happened, and next one is 9, so yeah, so current max will be changed to 9, so we will return 139. Okay, so this is it. It's not very difficult one. I don't know. Yeah. Okay. Left, make pair, left, tab. First, 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 first. Yep. Yep. So ooh. 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 The speed is kind of slow. So twice as low, I guess. Let's try one more time. Hmm? 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 A little bit faster, but there might be faster way. Hey, I think this is not bad. Maybe we go to this one. DFS 9 millisecond. Too easy. Yeah, very easy. Um, Size, Q size. DFS. So let's think about how we can solve DFS. In DFS, we lose the information about depth, so we have to pass the depth for into every. Well, we can maintain stack, but if we use recursive solution, then we have to add we have to pass the depth information. So inside the depth, well, it does not know, but yeah, we can also pass answer and then do the same thing like this. Yeah, I think this is okay. Yeah. So let's finish here. Okay. So I think I'm pretty good at most of the tree question, but array seems difficult. Yeah, complex array question.